Good morning, my dear grade 10. How are you today? I hope that you are doing great. Okay, so today we are going to continue Unit 1 Structure of Matter, Chapter 2 Molecules, and we're gonna deal with Part 4, and we are going to continue mole molecules. The objectives are 1. Determine the number of mole atoms, n atom in a given sample of mole molecule, small n molecule. 2. Determine the number of atoms, capital N atoms, in a given sample of mole of a molecule, N molecule. And 3. Identify the mass, small n atoms, in a given sample of a mole of a molecule, small n molecule. Introduction. We have 1 mole molecule of water, H2O, contains Na molecules of H2O, where Na is 6.023 times 10 to the power 23 Avogadro's number. And 1 mole molecule of H2SO4 contains Na molecules of H2SO4, that is 6.023 times 10 to the power 23 molecules of H2SO4, where Na is Avogadro's number. Note, in each mole of a molecule, there is a certain number of each kind of atoms forming that molecule. In a given sample of molecule, we are going to identify the number of mole of each atom, small n atom, present in a sample of molecules, as well as the number of atoms, capital N atom, as well as the mass of atom, small m of atoms. Objective number 1. Determine the number of mole atoms, small n atom, in a given sample of mole of a molecule, small n of molecule. Rule number 1. The number of mole atom, n atom, in 1 mole of molecule is given by 1 mole molecule of water, for example, contains 2 mole of H atom and 1 mole of O atom. This is the rule. Also, 1 mole molecule of H2SO4 contains 2 mole of H atom, 1 mole of S atom, and 4 mole of O atom. This applies to all molecules. Example 1. Determine the number of mole of each of H and O atoms in a given sample of 0.3 moles of H2O molecule. We are given then the number of mole of the molecule's water, which is 0.3 moles, and it's required to find the number of mole small n of H atom and the number of mole small n of O atoms in this given sample, which is 0.3 mole of water molecule. We apply the rule. We start by number of mole of each atom. So we may write 1 mole molecule of water contains 2 mole of H atom according to the rule. So the given sample 0.3 mole of H2O contains how much mole of H atom? So let it be X, or small n H atom. Therefore, X, which is the number of moles of H atoms, small n of H atoms, equals 0.3 mole times 2 mole over 1 mole, equals 0.6 mole of H atoms are then present in this given sample of 0.3 mole of molecules water. Now for the number of moles of O atom, we also apply the rule. We have in 1 mole molecule of water, there are 1 mole of O atoms. So in the given sample 0.3 mole of water, how much number of mole of O atom we have? Therefore, X, which is the number of mole of O atom required to be found, equals 0.3 mole times 1 mole over 1 mole, equals 0.3 mole of O atoms are then present in the given sample of 0.3 mole of water molecule. We have a note here. There is a general rule where here n is the number of mole, of course, as always. we may say that number of mole of atoms in a sample of molecule is equal to the number of mole molecule in the given sample times the number of atoms in one molecule. And you know that the number of atoms in one molecule is nothing but the subscript which is written at the lower right of that atom. Example, so this is the second method if you want. For n number of mole of each atom in 0.3 mole molecule sample given, we may say that applying the second rule or the second way, the number of mole molecule of water is 0.3. We multiply it by the number of atoms present in one molecule. So 0.3 times 2 equals 0.6 mole of H. For the number of mole atom of O, we may write number of mole atom of O is equal to the number of mole molecule in the given sample, which is 0.3 mole, times the number of O atom in one molecule, which is 1, equals then 0.3 mole of O. You can use the either of the method you want. Objective number 2, determine the number of atoms, capital N atom, in a given sample of mole of a molecule, small n molecule. So this is rule number 2 for determining the number of atoms in one mole molecule. The rule says that 1 mole molecule of water, we're taking as example water molecule H2O, but this applies to all molecules. We have 2 times Na of H atoms. So we multiply the subscript by Na to get the number of atoms in 1 mole molecule. And 1 times Na of O atoms. 1 mole of molecule H2SO4 contains then 2 times Na of H atoms. This is the number of H atom present in 1 mole molecule of H2SO4. 1 times Na of S atoms, and 4 times Na of O atoms. Example 2. Determine the number of each of H atoms and O atoms in a sample of 0.3 mole of H2O molecule. So we are given here the number of mole of water molecule, which is 0.3 mole. It's required to find the number of each of H atom and O atom, so capital N of H and capital N of O atoms in the given sample, 0.3 mole. Applying the rule for number of H atom in the given sample at first, we may write 1 mole molecule of water contains 2 times Na of H atom. The given sample, 0.3 mole of H2O, how much H atom would it contain then? Therefore, X equals capital N of H atom, yani the number of H atom, equals 0.3 mole times 2 times Na, which is 6.023 times 10 to the power 23 atoms over 1 mole, equals 3.6138 times 10 to the 23 H atoms, which are present in the given sample of 0.3 mole molecule of water. Now for the number of O atom in this given sample, we apply the rule where we have 1 mole molecule of H2O contains 1 times NaO atom. So the given sample, 0.3 mole of H2O, how much O atom would it contain? The number of atom is capital N, okay, as we have said. Therefore, number of atoms of O, okay, which is X to be found, equal 0.3 mole times 1 times 6.023 times 10 to the power 23 atoms, which is Na, Avogadro's number, over 1 mole. So we get 1.8069 times 10 to the power 23 atoms of O, which are present in this given sample of 0.3 mole of molecule water H2O. Note also we have a general rule, okay, where small n is the number of moles and capital N is the number of particles, here the atoms in a molecule. So we have number of atom in a sample of molecule is equal to the number of mole of molecule small n times the number of atoms in one molecule, which is represented by the subscript, okay, times Na, okay. Example, you can use this way, other than the golden rule. For the number of H atoms, capital NH equals number of mole molecule, small n, 0.3 mole, times the number of the atoms in one molecule, okay, which is 2 for hydrogen, times Na. So we get the same answer, of course, 3.6138 times 10 to the power 23 H atoms. For the number of atoms of O, we may say number of atoms of O equals 0.3, which is the number of mole molecule, times 1, which is the number of O atom in one molecule, and times Na, which is Avogadro's number. So we get 1.8069 times 10 to the power 23 atoms of O. So either you use this method in the note or the golden rule. Objective number 3, identify the mass small m of atoms in a given sample of a mole of a molecule, small n molecule. Rule number 3 says to determine the mass of atoms in 1 mole molecule, we have 1 mole molecule of H2O contains 2 times the molar mass of H atoms, where capital M is the molar mass. So the mass of H atoms in 1 mole molecule of water is equal to 2 times the molar mass of H and 1 times the molar mass of O. 1 mole molecule of H2SO4 as well has 2 times the molar mass of H atoms, okay? So the mass of H atoms in 1 mole molecule of H2SO4 is 2 times 1 gram per mole. And the mass of sulfur atom in 1 mole molecule of water is 1 times the molar mass of sulfur equals 1 into 32 gram per mole of sulfur. And the mass of O atom in 1 mole molecule of H2SO4 is given by 4 times the molar mass of each O atom, so 4 into 16 gram per mole. Example, determine the mass N of H atoms and O atom in a sample of 0.3 mole molecules of water. Given the number of mole of molecule in the given sample is 0.3 mole, it's required to find the mass of each of H atom and O atom in this given sample. Mass is small m. We apply the rule for the mass of each atom in the given sample at first. We have 1 mole molecule of water has 2 times the molar mass of H atom. The mass of H atom in 1 mole molecule is 2 into m. So the given sample, how much mass of each atom would it have? Therefore, X equals, which is the mass of each atom in the given sample, equals 0.3 mole times 2 times 1 gram per mole over 1 mole equals 0.6 gram of H atoms are present in the given sample of 0.3 mole of water. Now for the mass of O atoms, we also apply the rule 1 mole molecule of water has 1 times the molar mass of O atom. This is the mass of O atom in 1 mole molecule of water. So the given sample, how much what would be the mass of O atom in 0.3 mole of water? Therefore, the mass of O atom in the given sample is equal to 0.3 times 1 times 16, which is the molar mass of O atom, over 1 mole equals 0.3 grams of O atom are then present in this given sample of 0.3 mole of water. We have a note, okay, another general rule other than the golden rule, where N is the number of moles and capital N is the number of particles, here the atoms in a molecule. So we have the mass of the atom could be calculated by this rule. Mass of the atoms in a sample of molecule equal to the number of mole of the molecule times the number of atoms in one molecule, which is represented by the subscript, of course, times the molar mass of the atom. Example, for this same example, the mass of H equals 0.3 mole, which is the number of mole of the molecule, times 2, which is the number of H atom in one molecule, times the molar mass of that atom. So 0.3 times 2 times 1 gram per mole equals 0.6 gram of H atom. For the mass of O atom in the given sample, it's equal to 0.3 mole, which is the number of mole molecule, times 1, which is the number of O atom present in one molecule, represented by the subscript as we have said, times the molar mass of the atom oxygen, equals then 0.3 times 1 times 16 gram per mole equals 0.3 grams of O atoms. And thank you very much.